Vectors. Revision from National 5. A measurement which only describes the magnitude, i.e. the size, of an object is called a scalar quantity. For example, Glasgow is 11 miles from Paisley. The 11 miles, the distance, is a scalar. A vector is a quantity with magnitude and direction. So Glasgow is 11 miles from Paisley on a bearing of 065. That's a vector. Size and direction. Okay? The position of a point in 3D space can be described if we add a third coordinate to indicate height. So, indicate height. Sorry. So, what we're saying is, up until now, we have taught you on an X and Y axis. Okay? But now we want to talk about the X going along the way. The Y now goes back into the page. And the Z, which is the third component, now goes up the way. Okay? And if you look at this one in example 1, for the rectangle, F is 5, 4, 3. So that's your X coordinate, your Y coordinate, your Z coordinate. So example 1, a cuboid or a shape is always named by all the letters of the vertices. So it's O, A, B, C, D, E, F, G is a cuboid where F is a point 5, 4, 3. Write down the coordinates of A. Now, A is down here on the x-axis. Okay? So if it's on the x-axis, if F is 5, 4, 3, that means to get to F, we go along 5, we go back on the y-axis 4, and we go up 3. Okay? So that means to get to A, we go along that 5, we don't go back, and we don't go up. So we don't go back, we don't go up. So A is 5, 0, 0. D, let's change the colour of the pen, is up here on the z-axis. Okay? So, you're always going from the origin, which is O. So we're not going along the x-axis any, so that's a 0. We're not going back any on the y-axis, but we are going up on the d-axis. Because it's a cuboid, we're going up the same amount, which is 3. So D is 0, 0, 3. G, we're doing red. It's up here. Now G, going from the origin, we don't go along the x-axis, so we're not going to the right at all. So that's a 0. We're going back by 4. And then we're going up by 3. So we're 0, 4, 3. Now, next one. Oh, let's pick a colour. Let's go purple. Right, so for M, which is the centre of the face, A, B, F, E, okay, means that we go along the A, which is 5. We're going back half the distance, and then we're going up half the distance. So half of 4 is 2, half of 3 is 3 over 2, or 1.5. I'd rather a fraction than a decimal. Just saying. Okay? Whoa. Apologies. So, the rules of vectors. Vectors are either 2D or 3D. Okay? 2D, the rules work the same way. There's just an X and Y. However, vectors are always measured from the origin. Okay? That's the position vector. We'll talk more about that in a wee bit. So, for A, on our one, I think we're now using purple pen. So, on A, which is 4, 3, A, or A bar as we've called it here, is our vector. Okay? Because we're going from the origin to A. So we call that vector OA down here called, and we use the wee arrow above it to show what direction it's going in. Okay? Can also be called position vector A bar. or it could be an italics A bold if you see it printed. But because the coordinate's 3, 4, we still go along 4, 3, up 4. But this time to write our components, we do X and Y, but we do them vertically, not horizontally. Okay? And it's the same when we've got a 3D one. So this is directed, this is a vector OB. Okay, we've got an arrow. We didn't have an arrow in the last one, which is why I drew it. So to get from O to B, we're going along 2, back 5, up 4. So B is a coordinate. Apologies about the handwriting. B is the coordinate 2, 5, 4, but it is the vector 2, 5, 4, which is horizontal. You need to know the difference between a coordinate and components. Okay? Right, now, example 2. Now we're talking about the magnitude. The magnitude is the length of a vector. If we go back to OA, okay, if I wanted to know the length of that line OA from the origin to the A, I would use Pythagoras. It's a right angled triangle. So I could just use Pythagoras. That is how you find the magnitude. Now, magnitude is denoted though by 2 straight vertical lines round about the vector. We will not say the word magnitude. This is the annotation you're looking for. Okay? So it says here, if u is AB, then the magnitude of u is a squared plus b squared all square rooted. This is a quick version of doing Pythagoras. If it's vector u is ABC, then the magnitude is a squared plus b squared plus c squared all square rooted. Now, depending on how you were taught 3D Pythagoras, depends on how you would answer this question. Okay? Now, in examples above, find the magnitude of A and B. So we know that vector A bar, has the components 3, 4. Okay? So that means the magnitude of vector A is going to be 3 squared plus 4 squared. Which, if you remember your... Oh, I hate 2 equal signs in one line, but it'll do. And if you remember your Pythagorean triples, the answer is 5. Okay? Vector B was 2, 5, 4. So the magnitude of B is 2 squared plus 5 squared plus 4 squared. Which, if you let your calculator do the heavy hitting for you, is root 45. Now, what I do need to mention on this is surds. Root 45 is a surd. Okay? That is the square root of 9 times the square root of 5, which is 3 root 5. All surds must be simplified as far as possible. Okay? And that's your basics from National 5.